Yep. Yeah. Hi. Good morning, everyone. So my name is PC. You can call me PC. Uh, so today we'll go over some of the data engineering basics and some of the kind of a just introduction to data engineering, some demo, and what are the various components and why data engineering is very famous, becoming famous, and what are the various components, and what exactly we are going to handle as part of our further trainings that we will talk about today. Right. So if anybody has any questions just before I start the session.
Yeah, Suman here.
Yeah, hi Suman.
Can you, when you are telling this one, can you mention the prerequisite also?
Yes, yes. This session will have has that one slide exclusively
Thank
for
you.
that
Thank you.
prerequisite. It has. Okay. Yeah. So let's talk about Azure Data Engineering and what exactly data engineering and what are the various components it has and why it's becoming very famous in the modern data world. Why only Azure? Right. So these are all the things we'll talk about in the further session. But before that, let me talk about myself. So I think I also need to talk about myself. So I'm PC, I'm Purushottam here. So you can call me PC. So I have around 16 years of experience in DB, BI, ETL data engineering with various roles. Like I work as a developer, dev lead, architect in various companies. So right from small companies to Indian MNs to product-based company. So currently I'm working with one of the product-based company in Hyderabad, and I'm Microsoft certified Azure Data Engineer. So when I was started exploring data engineering like few years back, so I was getting more and more interest. Then I explored further. Then I attempted two exams. There were two exams at the time, DP-200 and 201. So which gives the certification of data engineer. So which I cleared at the time. Now it's only one exam, DP-203 instead of two exams. And I'm a Microsoft certified trainer because I do give trainings internally within the office. Also, I do take some of the sessions, and even outside, I do online and offline trainings regularly. So I got Microsoft Certified Trainer, which gives me the exclusive access for one of the good content from the Microsoft side. And interested in teaching and knowledge sharing. Yeah, I'm very much interested in teaching and knowledge sharing because I enjoy teaching and mentoring the people. Yeah, this is about myself. Yeah. So before Azure jumping into data engineering and what exactly data engineering, let's talk about what exactly it's a cloud and what are the various components of the cloud and why cloud is becoming famous instead of how it is different from the regular on-premise environment. Right. So if you see about like a few decades back, like whenever an application you are developing, suppose your application developing or you are hosting an application, okay, everything used to be person dependent, like human dependent, right? So suppose I have one application like web application I'm developing and I'm trying to host it, and my web application is an e-commerce application where I sell some of my products to western countries customers, right? So to develop that, what I need to do to host that application and everything I need to take care, right? So I need to take a physical location, right, a building, right, and I need to procure some servers, hardware, software. Then I need to develop my own application, then host on those servers, then take care of that performance, back end, front end, network, security, everything the person needs to take care, even though like from department to department, but still it's based on the persons, right? That was all about earlier on-premises environment, right? On-premise environment, everything used to be person dependent, right? And there were some limitations in that, because like say suppose in the same building you are you are having those servers and all. Suppose there is some building collapse, some power fluctuation happened, the every and some fire accident happened, then all your data, all your application is gone. The persons who are waiting for your application to come up, so they will be disappointed. Eventually you will be losing your customer base, right? And also say, suppose apart from that, some natural disaster happened, some tsunami or some earthquake, that time also your entire application is gone, right? And say suppose you have like your limit of your application is only 10,000 customers with 1,000 products, right? And some point of time, like Christmas season, like there will be massive what is a massive sales will happen, right? Because everybody start buying something, and what do you say, your company has, your website has good number of products with good sales and all, so definitely the customer base will be increased. So suddenly there will be a spike in the customer base, then your system will crash, right? The people will disappoint again, your customer base will lose, and eventually the trust or your the trust or your what do you say, the importance or your whatever the popularity that you gained your from your company or from your website, that is also will be lost, right? So these are all some of the limitations which were happening in the regular on-premise environment. So to overcome that, slowly the data engineering started evolve, right? Sorry, the cloud started evolve. So what happens in the cloud? So whatever I was talking about, the storage, the compute power, the servers, the networking, all those will be provided over the internet. So instead of regular human physical storage, physical thing, okay, all these services will be provided over the internet, so that you can use those services and you can take care of your application. So I was talking about the same application. You can take some VM servers, you can take care of OS, okay, you can use database from the cloud, everything you can take, and application also you can deploy, and the performance will be monitored by the cloud, right? The networking will be taken care, the security will be taken care by the cloud. The only thing is you need to develop application and host on the cloud, that's it, right? So those are the things like this. So all the human human related issues or operations were there, those are being taken care by the cloud provider, right? So delivery of computing services over the internet is the cloud. So in a nutshell, so whatever the services I was talking about, so if you talk about those services in this over the internet, that is a cloud. So we have leading cloud providers, like we have Azure, for which MS is a cloud provider. We have GCP, we have AWS, various cloud providers we have, right? So in this case, what happens? So like same example, some natural disaster happened. So whenever you're using the cloud, so your data, your application will be replicated to other regions. So if something happens in a particular building, some particular country, but the copy which is available in another region will come up, and so that there won't be any disturbance to the customers while accessing your application for that particular example, right? So this is how cloud has many advantages over on-premises. That is the reason all the applications started migrating from their on-premises to cloud applications. Right? Then let's talk about data engineer. Then what is a data engineer and what exactly data engineer does and all. Right. So before the data engineering and all, so let's talk about what is the data and all. So like if you talk about like 3 to 4 decades back when the software just started evolving, okay, and the people started using some database, right? It's like Oracle or SQL Server or something, whatever is the initial database. Okay. So when the people were using database, there was some concept of the database developer. So who used to create the, like design the database and implement this data, create procedure, create the tables and write some procedures and all. There used to be database developer who takes care of this operational database, right? So over the period of, and eventually the management, the top management used to get the reports out of the same database, right? The operational database. But over the period of time, as the data was growing a lot and a lot, right? The data was growing multifolded. The people realized that there should be a separate database for reporting purpose exclusively. We should not disturb this operational database, right? Then the terminology of data warehousing came into picture. Then the data warehousing developer, ETL developer, right? For the reporting, then is a BI developer. These are all people came into picture, right? Still the data was huge, but the data was very limit, and the number of sources also very limit. Like we used to have Excel files or data like web data, or some what do you say, this CSV files, like text files, or some database, Oracle database. Like the data used to be spread across the database, the files, and some what do you say, ERP data. Those data used to have, not more than that. Okay, so the job was very easy, right? And exclusively the data used to be used for the reporting purpose and all, right? Over the period of time, as the technology started evolving, okay, technology started evolving, we started having more and more sources for the data, right? We have social media, we have IoT devices, right? And we have so much data outside existing, right? Even if you take an hospital, the hospital have tons of customers, tons of people, right? Tons of patients. We have huge amount of the data. Let's say suppose you have social media, right? You are using the social media, then you are producing something video in that, then in the social media like YouTube, then there is a data. You're uploading a photo in Instagram, that there is a data. You're writing some message, some posting in Facebook, that is the data. You're tweeting some message in the Twitter, that is the data, right? So the amount of the data has increased, and everything is connected with the data, right? Say suppose you are going on the highway with the speed, then speed gun is capturing your speed, then there is a data, right? And capturing your photo, there's a data. You're going to hospital and you're getting scanned, all the data, the streaming data will be stored somewhere, then there is a data, right? All these kinds of data is there, and eventually over the period of time, the companies realize that we have so much amount of data with us, okay, and we should use this data for the better planning for the future, for organization development, organization growth, okay. Then the data scientist came into picture. So data scientist will analyze all the data, then it will create some AI and ML models for the better future, right? Give me a minute, 1 second, I'm getting one call. Sorry about that. Yeah. So then the data scientist will consume the data and he will prepare all AI and ML models and all those things. He does that, right? So that's about the data scientist. But so the data scientist, this data needs to be analyzed. The data is a huge, and data scientists need a proper data, right? It's in the, it's spread across multiple sources, multiple formats and all. So then then the role of data engineer came into picture. So what exactly data engineer does? Data engineer gets all the data spread across from multiple sources. He gets the data, he makes it a simple unified format and put it in a common storage, so that data scientists will access it and create AI and ML models, right? So the responsibility of the data engineer is to convert all the heterogeneous data into single format, a common format, and store it in a single place. That is the responsibility of the data engineer, right? So basically it creates a pipelines to transfer data into formats that are readable and usable for the data scientist, right? So converts in such a way that's suitable for analysis. The pipeline involves taking data from discrete sources and storing them in a single warehouse where data will be represented uniformly. That's what I'm saying, right? So the what is the pipeline? So whatever the conversion, whatever the extraction conversion is doing from end to end, all this package is known as a pipeline. So basically data engineer develops this pipeline so that data scientists will consume and create his own research and all, right? So that's how data engineering started evolve as the data was increasing lot and lot, right? So in a high level, the data engineer will have 4 phases. One is ingest, that is store, prepare and train, model, and so these are the 4 phases in the data engineering. So if you see here, data engineering has many data. Like if you see here, one second. So if you see here, we have structured data, unstructured data, like we have business data, we have like media data, all those data. Now it's the responsibility of the data engineer to ingest the data. Ingestion is nothing but extracting the data. So extracting or ingesting, excuse me. Yeah. So extraction or ingestion is one of the key phase in the data engineering. That's the first phase where we ingest the data, extracting the data, and we store the data into our ecosystem. Okay, one of the storage location. So ingest is a phase where you connect to all external sources and extract the data. Then you store the data somewhere in intermediate zone. There's a store phase. The next phase is prepare and train. So in this phase, what do you do? Using various technologies, depending upon the data, depending upon the volume of the data, we use one technology and we convert the data. We transform the data as according to the end user requirement, right? So once you transfer the data in the prepare and train, finally you load the data into data warehouse or any other application technology, so that the data scientist will consume the data, or developer will consume the data, so that developer will generate the reports out of it, right? So these are the 4 phases of the data: ingest, store, prepare and train, model, and so, right? So if you see this entire thing, so almost end to end, right from getting the data from providing into modern data, like a standard data, is the job of data engineer, and the consuming and doing AI ML models or reports is a data scientist or business analyst. Okay, does only generating the reports or generating the AI and ML models. If you see this entire end to end, 70% of the job is being done by the data engineer, who is kind of a backbone for any data project, and 20 to 30% is role is being done by the end user, who is data scientist or data engineer, right? So that is the reason, if you're onboarding any application to the data science or data warehouse, majority of the application, majority of the role is being done by the data engineer, right? So that is the reason you see tons of requirements, huge number of requirements in the market for the data engineer, because of his importance. So if you say, if you're currently onboarding a if you're onboarding a data science project, if you need 1 or 2 data scientists, at least 3 to 6 data engineers you need for the same project, right? Suppose you're onboarding a data warehouse project, so that also you need like 1 or 2 developers only, Power BI developers or Tableau report. But developing for the data warehouse, you need good number of data engineers, right? So this is at high level about the data engineering different phases. So if you see the difference between data scientist and data engineer just design, build, and arrange the data to be clean. So data scientist uses the clean data, create hypotheses and AI and ML models, but the responsibility of providing that clean data is in the hands of the data engineer, right? So I can say that data engineer is kind of a backbone of entire data science project, and without data engineer, there is no data science project, right? So this is a high level, the difference between data scientist and data engineer. Right? So at high level, what I can say based on the previous 2 slides, a data engineer is nothing but he does BI plus, he is kind of he analyze the BI plus big data. Okay, applying business intelligence on the big data. He analyzes the data and then he ingest it, then he process it, then he store it, then finally he takes care of access. So access is also one of the key thing, because you need to give the right access on the right amount of the data to the right people, right? That is also one of the key challenge of the data engineering. So data engineering involves all these different roles and responsibilities. So what is big data then? Big data is nothing but the data which is in a huge in the volume and spread across multiple sources, multiple formats is a big data. If you see the traditional big data project, what they were doing, they handle the data which is in multiple formats, multiple sources, and multiple the huge in the science. They use it to process all in the on-premise applications. But now, as the cloud started evolve, all those modern the legacy big data applications started using the data engineering technologies. So there are the three kind of projects will be there at a high level for the data engineering. One is when you're fresh onboarding the data science project, then you need to implement the data engineering. Otherwise, you're you are creating a data warehousing project. So that then also you need data engineering project, or you are migrating legacy data warehousing project from SSIS or Informatica and all to the data engineering, the modern data engineering, then the data engineering comes into picture. Or you are converting the legacy on-premise big data projects to modern data engineering, Azure data, then also you need Azure data engineering. So this is a way, because of these four different use cases, there are more and more data engineering projects in the market, and of course it leads into more and more demand to the data engineering, right? So this is the data engineering at high level. So what are the data engineering skills? We spoke about what is data engineer, what a data engineer does, and what are the various technologies you should learn. But before that, what's the skill set? What is the prerequisite if somebody wants to become a data engineer? So one is the SQL. SQL is the key skill for any data related activity, right? If it is a database developer, ETL developer, reporting developer, BI developer, data engineering developer, everyone interacts with the data very closely with the help of the queries, right? So that is the reason SQL is one of the essential skill for the data engineering. Next, data modeling techniques, because the data is in multiple formats spread across multiple places. The data is a huge, you should have right modeling techniques. So it's not a prerequisite for this course, but data engineer over the period of time should have this skill. And ETL and BI. So data engineers kind of will have extension of ETL and BI. So that is the reason he or she should have some of the basic concepts, basic terminology of the ETL and BI. So what is data warehouse? What is fact table? What is a snowflake design? What is a star schema? All these basic terminology skills he should have. Architectural projections. So one of the key element of the data engineering also architectural project. It means because there's various tools, various platforms, various libraries are there. Okay, so the data engineer should pick up the right skill at the right time for the right amount of the data, based on the data volume, based on the data size. You should pick up the right tool. So that is the reason you should have the architectural projections to pick up the right technology. Ability to connect the dots from source to destination. That means logical skills. You should have good logical skills to connect from the source to target. So what I need to do to transform all this data from multiple sources to the single format, so that data scientist will consume the data. You should have the ability to connect the dots. These logical skills you should have. Of course, the cloud you should have, because the cloud is essential for any data engineering. Everything done with the help of the cloud only. So in this case, we have Azure cloud. So Azure basics one must have. Then the Python. So all modern data engineering like PySpark, like Databricks or Spark pool in the data Synapse Analytics, we use the Python. So having Python knowledge advantage. So it's not a mandatory, but it's good to have, because some of the transformations we might need to write in the Python. So learning Python, whatever is related to the Databricks or PySpark, it's one of the good advantage, right? So these are the data engineering skill one must have. So who can start? If you're DB developer, because you already know like database and all, so it's very easy to switch to data engineering. So DB developer can start, ETL developer can start, DBS, because DBS day to day they deal with the data and they know about the database and queries, some of the basic queries. So DBS also is very easy to start. And also over the period of time, as the cloud is increasing its capacity, its features, over the period of time, DBA themselves may lose their what do you say, their role eventually to the cloud, right? So that is the reason it's a good start for the DBS to jump into data engineering. And big data developers, yeah, of course, because if you are a big data developer, you know, like data volumes and handling with the big data with various combination, various tools, is easy to shift to data engineering side. And also majority of the big data projects are slowly shifting to the data engineering, so it's also one of the good advantage for the data engineering. And data analysts, that means reporting developers like Tableau or Power BI, SSR developers are there. For those people also is very good to join. App developers, because if you're .NET developer and all Java developer, for you also is very easy to shift to data engineering, because in some point of time data engineering also needs some of the programmers, right? So that is the reason it's very good advantage if you have the combination of the programming language and as well as the data engineering. Fresher, yeah, if you don't, you are just starting your career into the IT, and it's very good start with the data, because most of the companies now started taking even the freshers with no experience, because there is a huge demand in the market. Demand for data engineers, yeah, so demand by data engineers is huge. So as per the latest survey, more than 50 to 60% of the job roles are being occupied by the data engineer, because of the various reasons that I explained in previous sessions. Yeah, so apart from that, we have exam DP-203, so which gives a certification of Azure Certified Data Engineer. So where various skill set will be measured. One is design, implement data storage, data processing, data security, data storage and processing, or optimization. All this will be measured as part of the DP-203 exam. So it is good advantage if you attempt this exam, so that it will add a good weightage to your resume, right? So these are all about the data engineering introduction, what all it has. And coming to the topics which we are going to cover, so there are a good number of topics which are going to cover. Let me go through that 1 second. Yeah, so we have ETL, data engineering basics. We're talking about, we'll talk about what is ETL, what is DWH, what are the basics of ETL, right? And we'll talk about Azure basics, what is cloud, advantage of the Azure cloud, what are the various terminology which are good to know for the data engineer Azure basics. Then we'll start with the actual data engineering thing. So Azure storage, will cover blob and ADS Gen2, in Azure SQL, Azure Data Factory, and Azure Synapse Analytics we're going to cover, Databricks we are going to cover, and some of the introduction for the Cosmos DB Stream Analytics. We'll give some introduction, the 1 or 2 examples with the Cosmos DB and Stream Analytics and security encryption, but in-depth cover will be done for the storage, SQL, Data Factory, Synapse Analytics, and the Databricks also. We will cover a good number of content for the Databricks. So you don't need to have exclusive another training for the Databricks. So in such a way, we will cover for the Databricks also whatever is required for the real-time experience. And one of the, apart from all these things, I was focusing also, I'll be focusing on Synapse Analytics, so which is kind of an integrated modern data engineering suite, in which at a single place you can perform all data engineering operations. Okay, Synapse Analytics is one of the very great tool, and it is going to rule entire data engineering market in next 1 or 2 years. So that also we are going to cover in detail. And for all these things, I listed down good labs hands-on, which we are going to cover. So at high level, it has only 36, but if I decompose further, it will be around 50 to 60 various sessions will be there, which we are going to cover into the lab. Right? So these are the all at a high level, which are going to cover. Any doubts?
Hi, PC Rohini here.
Yeah, hi Rohini.
Yeah, what are the things that you're going to cover in the Databricks? Like, will you cover Scala, Python in detail?
Scala, Python, I'm not going to cover. So whatever the what are the data frames, what are the transformations that we are going to cover, that we will be doing, that we will do using the PySpark. So we are going to use the PySpark.
So
So
your main concentration is on PySpark, not on the Scala.
not Scala, no, not Scala. We are going to use PySpark because it is one of the widely used language now in the Databricks. Because earlier the people used to use the Scala and all, but now as the Python started increasing its popularity because of the data science, even data engines also using the PySpark.
Okay.
Right? And here we'll use the data frames and data delta lake. We'll cover this delta lake streams and data frames in detail.
Okay.
Yeah, hi PC, this is Leela Krishna.
Yeah, hi Leela, please tell me.
Yeah, based on this training, can we complete this one certification, Microsoft certification based on our training?
So for the certification, see, this is not a certification, purely certification oriented training. So these are a mix of certification as well as the real-time use cases, right? So, but it covers almost 30 to 40% of the exam, because when it comes to certification, it'll be more of theoretical, right? But here we are concentrating more of practicality. So, but it covers 30 to 40%. It gives good hints for the exam. So you can extend your learning methodology from there, and you can you can attempt the exam very easily.
Yeah, okay. Thanks.
Yeah, and if it comes to modern data like DP-203, majority of the questions will be around Synapse Analytics. Okay, and anyway, we are going to cover Synapse Analytics in detail, so it won't be any problem for you to attempt the exam based on the training. But only thing is, you should practice more questions. You should read some content, blogs and all. So it will make you to comfortable to attempt the exam.
Yeah. Thanks, sir.
Yeah.
Yeah, hi, PC, I'm Raghu here.
Yeah, hi,
so
Raghu.
what is the duration of the course like?
So duration of the course will be 6 to 8 weeks and weekly 5 days.
Okay.
So it will be easily, it will take 40 to 50 sessions based on the my pace and based on the your pace.
Okay.
Yeah, and every technology, whatever I am going to cover, so it will be done based on the use case based. Say suppose I am going to cover some of the data factory, so I'll be taking one simple example. Then I'm going to cover all the related activities in that use case. I'm not going to say that activity 1, activity 2. I'm not going like from very basic level. I will not be teaching that. That doesn't help you. So instead of that, I'll take a use case. Then based on the use case, whatever the activities, what are the components it will use. So I will cover all those components based on that use case, so that it will also give you advantage of like trying to understand better and better understanding in terms of the real-time thing.
Hi, PC, Suman here.
Yeah, hi Suman.
How is the practical? You have separate lab will be there, or how it is?
No, here only during the course of time only. Say suppose I'm talking about data factory, then I'll talk about the overview and basic components. Then I will jump into data factory. Then I will start explaining about the pipelines and all.
So practical things we have separate user ID and all the things. Now, what you mean be? My question is data factory and these things with little practical experience required. How hands-on we can get.
So we are going to do hands-on in the during the class, right? I'll be explaining during the class, so that then you can practice the same thing once the class is over. So you'll be having your own Azure account, So with that, your own Azure account, you can practice the things, whatever I explain.
Okay.
And for after every session, after every session, so wherever it is applicable, I'll try to give some of the assignments also that you need to practice over your own Azure account.
Okay. So my other question is, it's like it's kind of one kind of DBA role. This is like
No,
how?
No, it's not a DBA role, it's a data engineering role. So I was talking about the previous example, right? Ingest, store, prepare
Correct.
and train.
Correct.
All those phases, all those operations will be done by the data engineer. So basically, it will develop pipelines in the data factory to extract the data. He will write some code in the SQL to transfer data, or he can write some code in the Databricks to transform the data. So depending upon the project to project, so the developer develops all these various pipelines.
So there is a DBA, separate cloud DBA will be there.
No. So database administrator cloud, there is separate certification,
Okay.
but there won't be like a DBA cloud kind of.
Okay. Because the way of role looks like DBA, that's why I asked.
No, it's not a DBA, right? We are not administrating anything. We are developing the solution for the,
Solutions. Okay.
yeah, we are developing the solutions.
Yeah, another point is who is the competitor for this? That means Azure.
Azure Data Engineering, we have AWS Data Engineering also. Of course, for the cloud, there is a fight between the AWS and as well as
Correct.
Azure. So the same way data engineering also, there is a competition, but Azure is increasing its market share day by day, every day. So I'm sure it's almost leading data engineering provider, I can say. And in the future, definitely it's going to be one of the leading data engineering provider.
So if I learn this one, I can handle the Azure also. Sorry, yeah, AWS.
See, the
Like,
main concepts will be same, right? So if you
okay, that's
Databricks,
what.
yeah,
Yeah.
the concepts will be same, only the technology changes.
Okay.
Yeah.
Okay.
So I see many people who shifted from Azure to AWS very quickly.
Okay. So your target for the changing the job, 6 months you are giving the time.
Sorry?
How many months it is, the course?
6 months? No, only 2 months. Maximum 2 months. 6 to 8 weeks, I told.
Okay. After that preparation and all the things, we can plan for next 6 months. We can
Yeah,
target it.
you can target of 3 months is good enough to hit the, to prepare for certification and exam point of view. If you combine these 2 months, so next to 3 to 4 months, you can crack the exam. You can crack the interview as well. It all depends upon how better you grab the things and how better you prepare yourself. Because my role will be 20%, your role will be 80%, right? So
yeah, obviously.
Yeah.
So the thing is, what about the experience level required this kind of tool? Because I am little experienced. That's why is it affected? If it is basic level, will be there. We need any advanced thing.
So if it's 2 years experience, that it should be good enough. Is that?
What about more than 10 years?
Yeah, further also is good.
Okay.
Give me a minute. Yeah, sorry. Yeah, so 10 years experience also, if you are database background and all. So for 10 years also is very good. 15 years also is very good. Because myself having after enjoying 10 to 12 years of database experience, I shifted to data engineering.
Oh, okay.
So it's, see, the technology started evolving only from past 2 to 3 years, right?
Correct.
So obviously, if you have 10 years or 15 years also, you can jump into this.
Yes. So is it SSIS and SSRS is required mandatory?
No, it's not mandatory.
Okay.
It's not mandatory.
Okay, additional skill. That's
So
it.
no, it's not a mandate. That's what I was saying, right? Even if you're a .NET developer, if you are a big data developer, then also you can do that. Even if it's fresher, also you can do that.
Okay, thank you.
Yeah. Anyone else? Leela, Raghu, Rohini, Suman. Anyone else? Any questions?
From my side, no.
Okay.
No, I'm fine.
Yeah, if nobody has any questions, so we can head towards our work now and enjoy the day. Okay.
Sir,
Thank
no,
you.
session wise, daily, almost every day it will be there, right, sir?
It will be weekly 5 days.
Okay.
If it is required, I will add Saturday also, but I'm sure there won't be on Sundays and public holidays.
Okay, sir.
I mean festivals, I mean to say public holidays, festivals. Yeah. All right. Okay
Yes.
then. Yeah. Okay then. Have a great day and all the best. Thank you.
So from tomorrow it will start, right, sir?
Not exactly tomorrow. I will let you know the dates. Maybe in this week only, but not tomorrow. I will let you know the times. Thanks.
Okay.
Okay. Thank you.
Thank you very much.
In any questions from anyone?